Hi, it's Moser with a quick tutorial on empirical versus molecular formulas. After this video, you should be able to distinguish between an empirical and molecular formula. You should be able to correctly determine the empirical formula for any molecular formula, as well as being able to identify possible molecular formulas for an empirical formula. You should already know how to write a chemical formula using atomic symbols and subscripts. So we'll start off with a molecular formula, C6H12O6, and this is actually the formula for glucose. And remember that that molecular formula refers to a single molecule of glucose. You knew that. And that molecular formula actually counts all of the carbon, hydrogen, and oxygen atoms in the molecule. Like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, and then oxygen, well, you know how this is going to go. 1, 2, 3, 4, 5, 6. That's it. A molecular formula gives the exact number of atoms of each element in a molecule. Obviously, molecular formulas all refer to, that's right, covalent compounds. So, what's an empirical formula? Well, while the molecular formula actually counts each and every individual atom, the empirical formula gives you the simplest ratio of atoms, and we find it by dividing each subscript in a molecular formula by a common denominator. So when we divide all the subscripts in C6H12O6 by 6, we get CH2O. That's the empirical formula for glucose. So, to clarify, the empirical is the smallest whole number ratio of each type of atoms, while the molecular formula is the actual number of atoms in a molecule. But wait a minute, can compounds have the same empirical formula and have different molecular formulas? Of course they can! Just take these. C4H8O4, C6H12O6, C10H20O10, they all have the same empirical formula, but they're very different molecules that behave in very different ways. For instance, only one of them, glucose, is the fuel used by your cells and the cells of most eukaryotes to provide energy. But yet, it has the same empirical formula as all these other molecules. Crazy, huh? Now, what about looking at an empirical formula and finding possible molecular formulas that would fit it? Well, if we have the empirical formula CH3, which of the following is a possible molecular formula that would have that empirical? Well, let's see. C2H6. Well, if we multiplied the subscripts there, or if we divided the subscripts there by 2, what would we get? Oh yeah, CH3, okay. Well, what about, so that works, that's a possible molecular formula for that empirical. What about C3H8? Well, what if we divided them by 3? That doesn't work. What if we divided them by 8? That doesn't work. C3H8 is already an empirical formula. Definitely not possibly a molecular formula for CH3. What about C3H9? What if we divided the subscripts by 3? Oh, we'd get CH3. That's another one that's a possible molecular formula for the empirical formula, CH3. Okay, do you know the difference between an empirical and molecular formula? Can you determine the empirical formula for any molecular formula? And can you identify possible molecular formulas for an empirical formula? Awesome. Get going.